What is a PLC? PLC stands for Programmable Logic Controller. A PLC is an industrial computer designed to control industrial processes, such as plant processes, a robot movement, or an automatic machine work cycle. What are the differences between a PLC and a normal personal computer? As you can see, the PLC looks very different from a standard PC. There is no keyboard, no screen, no other devices such as speaker, printer, or microphone. This is due to the fact that a PLC purpose is very different from the one of a standard PC. The PLC is placed inside an electrical panel of an industrial machine or plant. It is designed explicitly for its control. It must deliver hardware and software robustness, it has a lot of input-output pins, and it is a modular device. But what does control a system mean? It means to modify a system's behavior by acting on some of its physical properties. Whatever is controlling a system is called controller. Let's make an analogy. A person that is driving a car is using all of its tools in order to control the car. The driver is doing the same thing as a controller does. He controls and manages a process. The controller acts on its system using its actuators. The actuators are devices that are able to transform an electrical signal into another physical property, typically a movement. Examples of actuators are electrical motors, pneumatic cylinders, or water pumps. In the car analogy, the driving wheels, the pedals, and the gear stick are the actuators. The controller will also get some feedback from the system using its sensors. The sensors are devices that are able to transform a physical property of the system into an electrical signal. There are many different kinds of sensors: presence sensors, light sensors, temperature sensors, and many others. Even a button can be considered a sensor, as it detects whether or not it is being pressed. In the car analogy, the driver's eyes and ears are the sensors that allow him to get some feedback and information on the surrounding environment. So, a controller will receive data from the sensors and act accordingly, commanding the actuators. In most industrial systems, the controller is in fact a PLC. What is a PLC made of? The core of the PLC is the CPU, the central processing unit, that is actually the brain of the industrial process. The CPU stores the PLC software and reads the values coming from the sensor using input boards and sends command to the actuators using output boards. The union of input and output boards is typically called I/O. Typically, a PLC has also one or more communication boards, or modules, that are used to communicate with external devices, such as an HMI, a human-machine interface, the panel operator used to interact with the machine or process. The PLC may also communicate with many devices that require advanced protocols. This set of devices is typically called field, and the protocol used for the communication is typically called field bus. Now, let's see the origin of the PLC, how they were born, and what changed in the way they are programmed. Many decades ago, the control of industrial systems was carried out assembling panels of relays. Relays are devices that turn on and off. Panels of relays could be used for simple operations, but any modification in the system control logic led to a new panel being assembled. The system had therefore low flexibility, relays would break very often, they were expensive and had low energy efficiency. Panels of relays were replaced by PLC. They are programmable devices and didn't need replacement or redesign for new applications. PLCs needed less space in the electrical cabinet, they were more reliable, modular and flexible. PLCs are programmed using many different programming languages that we will see and learn later on the course. One of these languages is called ladder diagram. This language is based on the same structure of a relay panel, and it is an inheritance of that type of control system. It is a graphical language, and it was very easy to use since many PLC programmers back in the day had an electrical background and not a computer science one. Today, the PLC programming field is catching up with computer science, allowing PLCs to carry out different complex operations and applications with more evolved languages. There is a growing focus on software engineering for PLCs for people with a more academic background. PLC programming skills are very requested by many companies. Wherever you may find an original equipment manufacturer, you may as well find the need of a PLC programmer.